This is a shunt machine. That means that the armature is connected in parallel to the shunt excitation. This one is a double excitation machine. There is a shunt excitation and a series excitation, and the resulting machine that can be connected is a compound excitation machine. And this is a series one. The armature is connected in series with the excitation winding. This is a very important instrument. As you can see, it has two DC instruments, an ammeter and a voltmeter. And this one, which is a three-phase analyzer, AC analyzer, which gives all pertinent information on an AC application. It gives about 20 readings from currents, voltages, power factor, and so on and so forth. And it is what we are going to use at the end when we will go through an exercise, as I mentioned before. Over here we have two electronic instruments. This one is an RPM meter. It's connected to its sensor that we will see installed later on to measure speed. This one is a torque meter. Is connected to a load cell that we will also see later on to measure torque. Here we can see three examples of brakes. Now the brakes are going to be connected to the torque meter in order to measure torque, of course. Now, this is a powder brake. Torque can also be measured by what we call the arms and weight system. The two arms are connected to the brake, any of the three brakes, and by balancing the weights it is possible to measure the torque with a special formula which is given in the relative manuals. This is an eddy current brake which has a standard stator and a rotor which is a single piece of iron, let's say, in which eddy currents react to the motion and provide the braking action. This is a braking DC generator. It is actually a DC generator which, being loaded and driven by the motor, provides the braking action. All of them, as I said, can be connected to the torque meter, but it is also possible to measure the torque by means of manual system. Here we have three kinds of loads. We have a three-phase capacitor load. As you can see, each phase is adjustable singularly in 7 steps. This one is the equivalent load, three-phase load, but it's a resistive one. And this one is an inductive load. All of them are three-phase, 7 steps per phase. Obviously, the loads are normally used to test generators, both AC and DC generators. This one is what we call a paralleling board. Is used to make a parallel of two three-phase lines. One is entering here and the other one is entering here. It may be the public network with a local generator or two generators. Anyway, it uses the lamp dark method, which means that the parallel by switching on the switch can be done when all the three lamps are down, are off. Here we have two rheostats. The rheostat is a variable resistor, therefore it can be used for different purposes. It can be a load or can be a means for adjusting voltage and current. In certain exercises, they can be useful, and they are going to be used for the purpose that I just said.